All right, day 4 notes, thermochemistry. Today we're going to look at limiting reactants and thermochemical equations. These are very short notes, so we're just going to be adding in a limiting factor idea. So remember that a limiting reactant is the amount of reactant which will yield the smaller amount of product. Energy in a chemical reaction can also help determine which reactant will limit the amount of product that can be made. Here's an example. How much energy is used when 14.3 moles of hydrosulfuric acid reacts with 17.1 moles of oxygen gas? Here's our equation. 2 moles of hydrosulfuric acid with 3 moles of oxygen. This is going to be an endothermic reaction. We need to add in this amount of energy. Will yield 2 moles of sulfur dioxide and 2 moles of water. So let's go ahead and start plugging in our information. We're going to be using 2 different calculations because we have this amount of hydrosulfuric acid and we have this amount of oxygen gas, and we want to find out which one's going to be the limiting amount. So there's my known for this one. My unknown is how many kilojoules. I've got 2 moles of hydrosulfuric acid, and I'll need to add in 175 kilojoules. So for this reaction to occur, I've got to add in 1,250 kilojoules. I have this amount of oxygen. For every 3 moles of oxygen, I'm going to need to add in 175 kilojoules. For this reaction, I will need to add in 998 kilojoules. So the amount of energy that's going to be needed, how much energy is going to be used, is going to be 998 kilojoules. Let's look at one more. How much energy is produced when 13.11 grams of tin reacts with 2.715 grams of nitrogen? Here's our formula, and the first thing we're going to need to do is balance it. And then plug in what we have as far as the mole ratios. So when this is correctly balanced, you're going to have 3 moles of tin to 2 moles of nitrogen. We'll produce 1 mole of our tin. For this one, we know we've got 13.11. For every 3 moles of tin, we're going to produce 632 kilojoules. So the first thing we want to do is convert it to moles. So we've got grams to grams. Now we have how many moles, and then we're going to use our new conversion factor. For this reaction, it's going to produce 23.27 kilojoules. For our next one, we know what we're given. Again, we're going to have to convert that into moles. 28.02 grams per mole of nitrogen gas. We're going to use our conversion factor. 2 moles of nitrogen gas will produce 6.32 kilojoules. This amount of nitrogen will produce 30.62 kilojoules. So that's a greater amount. So this will be the amount that's actually produced. So let's go ahead and give that a try.